This is Rootul. This is question number 3 and 4, 5, basically Dijkstra's algorithm. Here's my solution for part 1. Basically, I'll just run through it really quickly. Making a class called vertex to store these variables. Creating a class called graph up here. You initialize the graph with the start and stop vertexes for the shortest path. Vertices is a hash. Set the distance of the start vertex to 0. All the other ones get declared to infinity up here. Adding edges is just adding each corresponding vertex to the neighbors array of that vertex and adding the distance to the edges hash. Solve is this complicated long function here. It's kind of annoying to go through, but all the variables are like well defined, so if you want to read through that, you can just read through that. Shortest distance, yep, grabs the distance to the stop vertex. Shortest path, this was a little annoying, but I basically had to go through all of the previous nodes and then append them to this empty array and then join the array so that you could see it. Down here, this is where I create the graph with all of the edges described in the homework. You have to call graph.solve before printing out shortest path and shortest distance. Let me just quickly run it for you. That should be the answer to that. And then go over to question 4. The benchmarks are in benchmark.text. I couldn't do n equals 1000 because it took too long to generate the graph. But I have n up to 100, and I have an explanation for why my n equals 100 times are actually smaller than my n equals 10 times. If you want to look at that, I'll run Dijkstra over here. That's the benchmark, and I'll quickly show you my script to generate. I had to add the delete edge function here, but scroll down, you'll see the new graph function, which is basically handling the probability, deleting edges, and so on. And down here is where we're running the benchmarks. All right, cool.